We think of the universe as divided into two distinct categories: physical matter that takes up space, and the intangible energy that moves it. Matter and energy exist on a continuous, interchangeable spectrum. Einstein's mass-energy equivalence is the rulebook for this spectrum, dictating exactly how objects shift from one state to the other. We are going to map the exact, measurable boundary where mass converts entirely to energy and where energy solidifies back into mass. First, we will look at how physical matter can be completely destroyed to create pure energy. Then, we will look at the exact opposite mechanism, the spontaneous creation of mass from a beam of light. In physics, these two inverse mechanisms are known as pair annihilation and pair production. These precise, observable mechanics occur constantly in particle physics. By tracking the strict energy accounting for both processes, we can prove that absolutely nothing is lost in translation. Crossing the mass-energy boundary follows a rigid mathematical transaction, where the universe's energy ledger always balances perfectly. To see how this transaction works, we need to build a model. The first requirement for annihilation is a subatomic particle and its exact antiparticle counterpart. The most common pairing used to study this interaction is an electron and a positron. When we set these two particles on a direct collision course, this text outlines the formal definition of pair annihilation. It is the process where a subatomic particle and its antiparticle collide, mutually destroying each other. At the exact moment of impact, both the electron and the positron cease to exist as physical matter. Their combined mass is instantly converted into pure energy. Specifically, that energy will take the form of two distinct gamma-ray photons radiating outward. Notice the geometry here. These two photons must move exactly opposite directions, a perfect 180-degree split. This trajectory is strictly required to conserve the physical momentum of the original system. Look at the equation at the bottom of the screen. An electron plus a positron yields two gamma rays. To audit this transaction, we can set up an energy ledger. On the input side, the matter side, we start with the intrinsic rest mass energy of both the electron and the positron. We also have to add any kinetic energy or velocity those particles possessed right before they collided. Now look at the output side. We have the combined energy of the two newly created gamma-ray photons. The rule of conservation dictates that the total energy of these photons must exactly equal the combined rest mass and kinetic energy of the particles we just destroyed. Zero energy is lost to heat, sound, or friction. It is a 100% efficient translation of state. This proves that mass can be completely subtracted from the universe, provided its exact energy equivalent is added. Annihilation shows us that matter is tightly packaged energy, waiting to be released the moment it contacts its antiself. Let's clear the model and look at the inverse process, creating matter from scratch. To do this, we need a specific environmental catalyst, the strong electric field surrounding an atomic nucleus. Next, we introduce a single high-frequency gamma-ray photon into this field. This defines pair production. As the notes state, it is the process where a high-energy photon converts into a particle-antiparticle pair when it interacts with that strong electric field. When the incoming photon hits the field, it vanishes. In its place, an electron and a positron immediately manifest and diverge. You are watching pure energy solidify into physical matter. The equation here is the exact reverse of annihilation. A single gamma ray yields an electron and a positron. But this raises a question. Why doesn't every photon of light create matter when it hits a nucleus? Annihilation happens spontaneously upon collision, but production has a strict energetic gateway, an entry fee. Look closely at these middle points. To create an electron-positron pair, the photon must possess a minimum energy of 1.022 mega-electron volts. We can deconstruct that specific number by returning to our energy ledger, this time moving from energy to matter. The physical rest mass of a single electron requires exactly 0.511 MeV of energy to exist. The positron requires an identical 0.511 MeV. Add them together and you get 1.022 MeV. That is simply the baseline cost to bring both particles into physical existence. So, what happens if the incoming photon carries more than that minimum required energy? The laws of conservation forbid that excess energy from just disappearing. Instead, any energy beyond the 1.022 threshold is instantly converted into the kinetic energy of new particles. The larger the surplus of energy the photon brings, the faster the newly forged electron and positron will fly apart. Energy can only create matter if it meets the exact minimum threshold to pay for the mass. Any leftover currency dictates the velocity of that new matter. When we place the annihilation and production engines side by side, the symmetry becomes clear. Looking at their respective equations, they are perfect mirrors of one another. On the left, matter mutually destroys itself to radiate energy out into the universe. On the right, a concentrated threshold of energy collapses to manifest new physical mass. Whether you read the equation from left to right or right to left, the underlying mechanics do not change. Pair annihilation and pair production prove that while the universe freely trades back and forth between mass and energy, the total energetic value of reality remains perfectly, permanently conserved.